introduction. Thank you for inviting me to speak about the topic about digital workflows in dental practice and about intraoral scanning. My name is Ingo Baresel. I'm a GP. I'm working in Kadolsburg in South Germany. We do intraoral scans now since 2012 and did about nearly 4,000 scans now, mainly for our restorative treatments, but even for Invisalign or in our orthodontic clinic. So as you see on the pictures, I'm a little bit of scanning nerd. So we try to do everything digital. We try to use many scanners, to test many scanners, to see the differences, how they work. And yeah, you can say that's crazy, but it's really a lot of fun. So this is the problem, and this is one of the main problems why patients don't like analog impressions. These are not my patients, lucky me. These are nice pictures from Facebook and so on, but they look quite real. So I think they were really done. And this is something we don't want to see anymore, and which we really don't need. In every one of my lectures, I say intraoral scanning made me a better dentist. And why? Just because we see things that big on a screen. And if we see there is something wrong, we can correct it. There's a nice study of the University of Munich by Professor Elof and Professor Güth that says the quality of your preparation increases significantly by using intraoral scanners. And why? Same reason, because you see things that big on a screen. And you have the possibility to correct your problems. So in this case, you see there's not enough space. There's not enough space for restoration. Sometimes with analog impressions, we see that just when the model reaches the lab and they call us and say, oh, there's still a space for the restoration. No, you see it with a scanner at once, and you have the possibility and you have the chance to correct it. So reduce it in the mouth, cut it out on the scan, and rescan it. And if there's something wrong on your margin line, or if there's some saliva or whatever, and something is not quite clear, you can improve your scan. And this makes me a better dentist. And we were looking at the data from our lab. In 2012 to 2016, with the former generation of scanners, we made a little research, which we continue now. And we looked at 2,500 digital scanned cases, and we compared them to analog taken impressions. And we looked at the returns to the lab due to a bad fitting, because this is our main goal. We want to have perfect fitting restorations. So, and if you look at this, we have about 3.5% of the work coming back due to a bad fitting in analog dentistry. And we have about 0.5% returns due to bad fitting with digital impressions. And this is from 10 doctors with different intraoral scanners, and remember the former generation of scanners. So now it will become even better. Again, this makes me a better dentist. Going digital makes me a better dentist. Usually, when you think about going digital, you have to ask yourself, first of all, what materials do I use? When you say, I just use gold, okay, then perhaps you can do this digital, but it's not that easy. But if you use all the other materials like zirconia, like Emax or whatever, this is milled, this is done digital. So why can we not send digital data to the lab? Because the lab needs digital data for that. Second question is, do I have any advantages working with digital workflows? The next question, and I want to show you today, yes, you have so many advantages. I will show on a few minutes ago. So the problem always is, we have in Germany about 10% of the dentists working with a scanner. But why are not more people working with a scanner? And everywhere I go around the world, I get the same answers. Scanners are not accurate enough, they are too expensive, they are too slow, and scanning is much too difficult. And I want to show you today, in the next minutes, that's not true. So think about too expensive. If you have less returns due to a bad fitting, you save that much money, and your labs save that much money because you don't have to do things twice. And our time is our money. So it saves you money when you have to do less remakes. Let's talk about scanning is difficult. It is not. It's really not difficult. And scanning is fast. I want to show you in these videos that scanning is faster than taking analog impressions. You see on the left side, one of my assistants is doing an alginate impression on upper and lower, and me scanning with a Trios and with an iTero, the same patient without any assistance. And you will see how fast I am with scanning. And I programmed the scanner. I have no assistance, but it's really easy. So what is important? Look at me scanning at the right side. I'm just looking to the monitor. I'm not looking to the patient's mouth. And if you are able to do this, you can scan very, very, very fast and accurate. But if you are not able to do this, you have to train more. Because scanning allows you to scan a patient, as you see, in between 3 minutes. And this was including the palette and everything else. So with the Trios, we have been ready in 4 minutes, just because the software was a little bit slow because it was a better software, but usually with scanners, and it doesn't matter which scanner you use. The modern scanners are all fast, and they all scan a patient in between 2.5 to 3.5 minutes. She will be ready in 6 minutes and 31 seconds. So I'm nearly twice as fast with scanning than doing analog impressions. But the main question always is scanning really accurate? And I can tell you, yes, it is accurate. Look at these studies. On the left side, you see a study of Professor Mehl from the University of Zurich, which says nearly every scanner which is on the market now, and we talk now about full arch scanning. We don't talk about single teeth. We talk about full arches. And this was always a problem in scanning in former times. We have accuracy regarding the whole arch from under 50 microns. Most of them were between 20 and 30 microns. So this is absolutely accurate. On the right side, you see a study again from the University of Munich from Professor Güth and Christine Keul. They compared scanning with iTero and doing an analog impression, casting it and scanning it, and they compared the accuracy. So scanning with an intraoral scanner was a little bit more accurate than doing analog workflows. Again, regarding full arch scanning. And there's even a nice study, which is quite new in the middle, which compared 12 intraoral scanners. And again, same result. Scanning is absolutely accurate. So, but there are many differences between intraoral scanners. And we'll talk about this because this is even a reason why people don't go digital, because they don't know what scanner they should buy. So I will show you a little bit the differences between the scanners. There's not just the best scanner on the market. No, there are different scanners and every scanner fits to some offices. So you have to find the scanner for you. And you have to think about, what do I need? And then you will find the best scanner for your choice. And I will show you a few of the arguments you can take to buy one. So mainly we use scanners for restorative dentistry, but we can even use them for diagnostics. I will show you later. And for sure for tooth movement, means orthodontics and aligner therapy. These are the scanners which are on the market today. There are one or two others now coming to the market, but these are all different intraoral scanners. So what's the difference between them? Let's start. We talked about accuracy, and the main thing in dentistry is accuracy. So what did we do? With our test here, we scanned a little printed model. We scanned that tooth. So you see the lines on the surface, the typical printing lines, and then we looked first of all at the point clouds. These are the point clouds the scanner measured on the surface. And as you see, there are some differences. So if you see the left upper picture, there are many, many points. There are less points on some other scanners, but this is not that important because you have to have the right points and you have to combine them to triangles. And now you see the STL data with the triangles. So even in this case, you see there are differences between the number of triangles, between the size of triangles. But what is important with these triangles? It's important that at regions with like the margin line or with little defects or things like this, like the little dot in the middle, the scanner has to have smaller triangles. He has to detect these areas and there make very, very small triangles. When you have a flat surface, it can make the triangles a little bit wider. So it's not important to have everywhere narrow and small triangles, but you have to have small triangles at the right areas. So again, remember this, and now I will show you the surface. And there are really a few differences when you look at the surfaces and at the lines. I go back a slide, so look at the lines and look at the lines now. So if you see the MEDIT, for example, you cannot do a restorative scan without HD because HD makes the quality much higher. And if you see the other scanners, there are a few differences. Perhaps that's not that important because we have a gap of cement from about 60 to 80 microns. But you see some differences. For me, what is the main thing, how I choose a scanner, is the scanning strategy. We need a smart scanning strategy. First of all, this is the scanning path. That means, and this is the same with nearly every scanner on the market, you scan the arch from occlusal, lingual, and the buccal side. This is the same with most of the scanners. But the scanning strategies are different. So most of the scanners want you to scan the overall situation. That means you take out all your retraction aids, doesn't matter if it is 1, 2, or 10, and then you scan occlusal, lingual, buccal. This is sometimes a little bit difficult because you know this from analog dentistry. If you have to take out all the retraction aids, the problem will be that you have saliva coming into it, you have some blood, you have collapsing gingiva, you have the buccal areas, so the cheeks. So sometimes this is really difficult. And when you have to follow the scanning path with occlusal, lingual, and buccal, sometimes the tongue moves about your preparated teeth. So you have to afterwards look at your scan and cut out some areas, rescan them, cut out some areas, rescan them, and so on. So this is analog dentistry. This is the same like analog dentistry. I don't like this scanning path, but with many scanners, you have no choice. You can even do a pre-preparation scan with some scanners and cut out, the scanner is cutting out the preparated teeth and you rescan just those areas. This makes it easier, but this is not working when you have 10, 11, 8, 9 preparations in a jar. So there's a third scanning strategy where you scan just the one after the other of the preparated teeth. And afterwards, you scan the whole arch, and I will show you this in a little video. So you scan just one tooth for a few seconds, then you take out the retraction aid with the next one. You go to the next one, press the button, and scan the next one, just this tooth. And you go on, depending how many preparations you have in between this arch. And afterwards, you go back to the patient's mouth and scan the whole situation. And the scanner is adding this single scan restorations with a high resolution into this scan. So you have time to care about one tooth after the other, and you have not to take out all the retraction aids. So this is, for me, one of the main reasons why I choose a scanner, because it makes life easier to me. And when I go digital, this must make life easier to me, because otherwise I don't have to do it. The second point is the position of scanning. So look at me in this video. I'm placed behind the patient, and this is for me more comfortable. I will show you later in the live scanning than sitting in front of the patient, because you have much more control about the tongue, about the cheeks when you're placed behind the patient, and about 80% of the patients of the dentists are scanning behind the patient. But you have to be able to have settings where you can choose this. So otherwise, you have this position sitting in front of the patient. And this is, for me, not that easy like sitting behind the patient. And again, 80% of the people are placed behind the patient while scanning. So what is the difference? Why is it necessary to have settings to choose this? Because look at this little window. I told you at the beginning, I'm just looking at this little window when scanning. But if you want to sit in front or behind the patient, you have to be able to mirror this window. Otherwise, your scanner moves to the right and the picture moves to the left. And this is working like with a mirror. And this is not very helpful. So you have to have settings if you want to choose the position you like. Otherwise, you're always forced to sit in front of the patient. A color scan is even very important. Why? Because, first of all, some scanners say we have open STL files. You can do with these files whatever you like to. I don't want to have STL files because STL files are not colored files. Sometimes you need them, but especially for setting margin lines, you want to have some color that you can switch between the colored and the non-colored mode, like in this example. That makes life easier to you to set margin lines. But not every scanner is able to do this. You can perhaps scan with a colored scan, but if you then export an STL file, you will not have a colored information because STL is a non-colored data. So think about it. You should have color even in the lab. First of all, for setting margin lines. But the second reason is, most of the time, when I don't forget it, oh, I'm sorry for the German, we're marking the occlusal points. And afterwards, after scanning, you scan these blue dots from our occlusal points together with the scan. And then you can check on your scanner if the byte setting is correct, because the scanner does the byte setting automatically. I will show you in a little video. Look at the red dots. The red dots are the contact points, and the blue dots on the teeth are the original contact points. And the red ones, these contact points were detected by the scanner. So if they are in the same place and have the same dimension, you can be sure that your occlusion is perfect. So look at this. You have the red ones, you remove them, and you see the blue ones. And back, the red ones, the blue ones. Same size, same dimension, same region. And the lower again, You see again, blue and red ones are absolutely the same. And now you know you have a perfect match bite. And when you can send this to the lab, you have an occlusion protocol for free. So this is the second reason why it's important to have a color scanner, and you must be able to send this color to the lab. Card or laptop? This is even a question. Some of the scanners you can just buy as a card version, and some of them you can buy just as a laptop version, and some of them offer both. The requirements of your dental office, of your clinic, are important, because if you have several levels or you have 3 offices and want to travel, then it's easier to have a laptop version. But I don't like laptop versions. Why? Because cards are much easier to use. You just grab them, bring them to the next room, grab it again, bring it to the next room, and you don't have to carry a laptop and whatever. So, and imagine you have a scanner, you have a power supply, you have a laptop, and so on. So think about what I said. We are sitting behind the patient while scanning. Where do you put the laptop? On the patient? So should the patient keep the laptop holding? This is not possible. So, and you have so many cables and so on, and you have to grab them all and carry them to the next room. This is not helpful. And what is the solution? The solution is that many people build things like this, again from Facebook. But now think about, we have difficult times at the moment. We talk about hygiene, hygiene, hygiene. How do you clean this? How do you clean a laptop? So if you want to buy a laptop version scanner, ask the company if they offer you something like touch monitor, which you can clean, because when you want to improve your scan, you have to cut out something. I do this with my fingers on a monitor, which I can clean afterwards. You cannot do this with a mouse or something like this. So even really important to think about. And the handling is even important. A few things. On the left side, you will see a video of a scanner where you have to place the scanner into patient's mouth, then press the button, but you don't see where you are. So the problem is if there's a tongue or a cheek or some different problems with the space, perhaps you scan the cheek or the tongue because you don't see it, because you go to the patient's mouth, you don't see anything, you press the start button, and it's once it starts scanning. So lucky me, I was on the right way. But the other possibility is you grab the scanner, place it to patient's mouth, you see where you are, and then start scanning. A little tool, but very helpful. This is even a great tool with scanners. So this is a possibility not just to scan the bite situation. You can scan how the patient is moving. So you let him move the teeth and you record this with a scanner. And afterwards you get this. This is your scan. And the scan is moving, and you can transfer this data to the lab and then import it to the designing software. And this is so helpful because it makes it integrates the function into your work. And this is what we always talk about every day: function, function, function. What is even important is you have to be able to reopen the scan. That means usually after sending a scan to the lab, you cannot reopen it. If, for example, you have 10 crowns on the scan and your lab says, oh, I'm sorry, doctor, we found there is too less space in one area, or we found there's a problem with the margin line, or it's super gingival at the incisors, you have to correct it. Usually with many scanners, you have to start scanning everything from the beginning. So complete new case, you have to set 10 retraction aids and scan everything from the beginning. But there are even scanners on the market where you can again get access to the scan. So this is something very important. I will show you an example. In this case, I got the scan back, so it's a demo case. We marked the area black on this tooth. So the lab sent it back to me and said, no, there's something wrong. And what I'm doing now is just, I use the rubber function, I click on the rubber, then I mark the area which should be scanned from, again, with my finger on the monitor, not with the mouse, and then I click on scan it. We go to the patient, place the wand, click start, and that's it. So think about this too. You have to be able to reopen a scan. And this is something you can add for sure. You can make DMG measurings and you can add them to your scan, and the labs can import this to their designing software. You will have completely individual movements. And then you can do everything digital. You have an unlimited use, like cases like this with many, many crowns, or like this. Quite easy. Or look at this case. And now think about, again, think here about the scanning strategy about what I talked before. It's much more easy to take out one retraction aid, scan it, or the next retraction aid, scan it, and so on. Then to take out all the retraction aid and scan this case occlusal, palatal side, and buccal side. But it's possible with every scanner. And then you have the choice. You can do with the scan whatever you like to. You can send it to the lab, but can you even use it for chairside dentistry? What do you need? You need a scanner. You need a designing software. The software is now out from 3Shape and Exocad, chairside softwares, and you need a milling machine. For sure, there is now the CEREC system missing. Because everybody knows it, and CEREC is one of the greatest systems for chairside dentistry. But even with the other scanners, you can now do chairside work. How does it work? You have so many options. You send the scan from the scanner directly to the scanning software. You import it. You can choose whatever you like to, material thickness, all the options. You are open to change as you like to. And then you start. You're marking your margin line, and I can tell you, if you have to set your margin line yourself, you will be even more accurate with your preparation because you have to do it yourself, and you can not rely on somebody at the lab who you hope is finding your margin line. So afterwards, the tooth is placed. You can correct some things you like to. This is really, when you have a little bit of experience, this is not difficult. And after that, you mill it. So from when you're fast, you need about 5 minutes for designing. 20 minutes depends on the material you use or 25 minutes for the milling, and then depends what material you use. If you have to just polish it or you have to burn it, depends. But then you can bring it to the patient's mouth, and after 1.5 hours, the patient leaves your office and is completely done. And patients love this. You can do it, but you don't have to. You can even work at left side. You can even scan implants. This is so helpful because it makes life so much easier to you than in analog industry. The important question is not, is the scanner able to scan implants? No, the question is there a digital workflow to your implant system? This is offered either by the original company which produces the implants or by third-party companies. For most of the implant systems now, there are digital workflows, but please talk to your lab because they need the libraries for those scan bodies. So talk to them, which scan body you want to use for your system, and please pay attention. Don't use, if possible, round and parallel scan bodies. Use some scan bodies with structure, so with asymmetric structures, because it's much more easy to scan, and you will make less mistakes with scan bodies which have structure. What is really a nice tool is the immunity implant concept. So that means this is a case where we place the implant, we put the scan body on, and after 20 seconds of scanning, it was done, and you can send this to the lab. And afterwards, you get, for example, if you like to, a healing cap, an individual healing cap, because especially for molars don't go to the patient's mouth with round structures. And our healing caps, which are offered by the companies, are all round. So no molar has a round shape. So with individual healing caps, they are produced while the implant is healing. For reopening, they are back at our office, and then you can place them, and then you have a much, much more aesthetic situation than you have with a round healing cap. The great advantage of scanning implants is you can get easily access to the implants, even in the molar regions where it's really difficult to have analog impressions. It's quite easy. You just screw in your scan body, scan it, that's it. Really easy. But you can even scan the emergence profile in a second scan and send even this to the lab. And this makes the lab life much more easy, because when you get your crown back, you will not have that much pressure on this area, because the lab has now an additional information about the gingival surroundings, about the emergence profile. And as we all know, we have to care very much about the emergence profile. This will not have pressure, because otherwise we will get problems with the implants. So quite easy to get a new information to the lab just with a few seconds scan. Scanners can even be used for diagnostic. So I want to show you a few examples. You can use them for patient monitoring, so you can have a comparison over time. I want to show you, these are a few examples from different companies which offer this on their scanners. I want to show you a little example how that works. You have two scans. No, I'm sorry. Back again. So I hope that the video will start now. Yeah, it does. So you choose your patient, you choose which scans you want to compare, for example, from last year and this year, and then you see marked with a color where there are changings. And then you go to this area and you see before and after. So there has something changed. We have some gingival recessions in this area, or like this, you have some tooth movements. Perhaps after some orthodontic work, you can check if there are some differences. So this is even a very, very helpful tool. And we have caries detection. And this is how we use caries detection. I will show you a little bit later live how we use it. I want to show you a case. This is a patient where you see nothing at all with your eyes. We have on the medial side of the molar, we will find some caries. After scanning, we saw there is something wrong on the medial side. You see the animal has like a white spot. And this is really a small one. This was one of our first cases. We can now discuss if this should be treated, but you see it. Again, you see this area on this scan and the mesial side, and you see it's through the animal and touching the dentin a little bit. When you look at the X-ray, you don't see nothing at all on the X-ray. But when you open it, you see same size, exactly the same size as we saw on the NIRI. So I love this tool. And in the beginning, as they asked me if it's so helpful for us as a dentist to have a caries detection and a scan, I said, no, nobody needs this. I have X-rays, I have my eyes, I have other tools, so I don't need this. But luckily, they didn't listen to me, so they built it, and I love this function. I will show you later on live. So after this, with just a small restoration, this thing is done. And just remember, you have children, and with children, they have such a thin enamel on their milk molars. So you can, without any severe radiation, with a really harmful radiation, you can show this and look at this. And if you will tell the parents, you don't need X-rays anymore, you can just look at this with a scanner, they will love you for this. So very helpful in treating children. And now we talk about splints. I will show you what we're doing now. We will now go to the live scan, and hopefully all what we planned is working. So now it will be, we will be going live. I will show you how we're doing splints and how you can do together with DMG, with this really great tool they offer now, and what will be even greater in the future, because they work on many, many, many fascinating things. We will show you together how you do this in your office, how you do splints in your office. This is a situation where we were taking the bite. We did this already now with our patient here on the chair. And then we will scan it from the one side, from the other side, and from the front with a 3-point bite scan. And then we will get this situation on the screen, because the scanner is not scanning the bite itself, it's just an information how to orientate the upper and the lower arch together. So I'm a great fan of Professor Axel Buhmann, and I did all my lectures at his clinic. So we already know in which position the jaws belong to each other, and I will show you now with live scanning how this all works. So I will stop sharing my screen, and we now go to the camera. Yeah. So we go to the camera, and I hope all this works. We have a patient on the chair. So I hope you can hear me even speaking with so, okay. Thank you for being our patient today. And I will show you now, first of all, the setup of the scanning. So we see the scanner. Okay, we see the scanner placed in front of me. And we're now starting with the lower jaw. First of all, we will show you scanning itself, and then we will, with the upper, switch to the scanner, and you will see the scanner itself. So, you see me? I'm placed behind the patient's mouth and I'm scanning with my left hand. Also, I'm a right-hander, but I place behind the patient and I scan with my left hand. So I just will see, I will just look at the scanner. We start now the scanning, and you will see how fast we are with scanning. So we are ready for occlusal side, lingual side.
Dr. Baresel?
Yeah.
Yeah, so the sound is not so good at the moment.
Do
Sorry
you hear
for.
better now?
Yeah, yeah.
Okay, we just tried.
Yeah, now it's better.
Now it's better. Okay, then I'll speak
Yeah.
without.
Yeah.
So you see me scanning. We are already nearly ready with the lower jaw, and we will now switch to the scanner, and you will see me using the scanner live. So the lower is already done within a few seconds, and now we switch to the monitor. So you see now my scanner. This is the scan of the lower. And we now switch to the upper. And I will show you a little bit of caries detection. So we can now enlarge this picture. We can use the scanner as a camera, but we can even use it as an examination tool for caries. So look at this. And we can go through, and as you see here, you see this area here on the monitor, on the medial of the second premolar. This is some carious lesion. And we can go through and through and through and through. And you even see here, there's again some lesion. Okay? And this is what I love about caries detection. We have some x-rays from her. You don't see anything on her x-rays. But now I want to show you scanning. So you go back. And we now will scan the upper jaw. So this is the scanning of the upper jaw. And this is again quite fast. We go to the palatal side. So scan the palatal side. We go to the buccal side, we scan the buccal side. Okay. And that's it. So everything is scanned. Sorry, my cable is a little bit short because the scanner is that far away. You see, I scanned some buccal areas. The modern scanners all have an AI. They are removing all those areas, as you see. So really, really, really easy. And we now will show you. We put it in the bite, and we know the bite. So you see those arches now are appearing. The patient is closing the mouth. And and I will show you now, this is the situation in the mouth. You see, we have the bite splint in the mouth with the position we want to have the splint, and we now start scanning. On the one side, okay, that's it. On the other side, that's it. And the third one, at the incisors, that's it. So this is done. And you see, these are just a few seconds. So now we will just have all those things calculated. This is just 1 or 2 minutes. No, it's already done. And now I will go back to the scanner, and now you will be able to send this, and we will send the data, and that's it. So really, really, really easy. So I will go back now to share my scan, because we want to show you now, together with Mr. Oberhofer, how the new platform from DMG works. And now the scan is sent. You can use now all this scanning data and do whatever you like with it. And I will show you now the new Now we are here. You see now my screen. This is now the screen, and we go back with the camera. So we have so many things to, okay. Okay, works perfect. This is the new platform from DMG. And this is so great and so easy, because you now can design them yourself. Your lab can design it. It's a cloud solution. And I will show you how easy you can make a new case. So I'll just log in, and this is the starting page of this website. You go select a new case. So it's a Mrs. We make now, we don't say her name. She has a patient ID. Her birth is, as you see it, and you can choose which dentist. It's me. So, and this is everything. So you go next step. At the moment with the system, you can just do bite splints, but in the future there will be added many more options, like model printing, or perhaps like printing TAMs, all the things like this. So, but at the moment we choose the bite split. There's one material at the moment available, so we choose this material, and then we want to do today it in the upper. We want to do a splint today in the upper. So we go on. If you want to, you can add some additional comments. And we save and upload the files now. So you now have to know where your files are. We want to have the lower jaw. So here is my lower jaw. And this jaw is including the bite. So I transfer the bite situation as I scanned it directly to this software. We take the upper. So we have the first one is already uploaded. The second one is uploading now. And now everything we scanned, including the new bite position, is ready. So, and now we upload the files. We want to have the bottom. We just wait a little bit. I'm too fast. So here is it. This is the button done. So, and that's it. And now Mr. Oberhofer will explain you, and I'm placed with my laptop here in South Germany, in Karlsburg. He is now in Hamburg, but he has already access to all this data. So for now, I'm through, I'm done. I will stop sharing my screen, and I will now hand over to an Oberhofer, and he will explain you how the software works. So thank you, and all the questions perhaps you have, we will discuss later.
Yeah, thank you, Dr. Baresel. And as Dr. Baresel already told you, now I have access to the uploaded data because it's cloud-based. And I will show this to you at first, so you can see that this is all in real time. I'll sign in with my access data. And here you can see the patient he just added to Dentamal Connect. It's from today. Dr. Baresel added this patient, and if I click on this button, I come directly to the last point where he stopped. So in finding the model axis, but this only in the beginning. Now I'll just start with some presentation as well. So I will show you my presentation. Is it visible? Perfect. So at first, let me talk a little bit about the areas of application where we can use 3D printing in this moment. So there are various indications which you can use using 3D printing, which are starting from impression trays, going over surgical guides, bite splints like we will do today, castable structures, models in all variations. You can print gingival masks for models, and you will be able to print flexible soft splints and even denture bases and crown and bridges. And all these materials are or will be available in a short time, and everything with the same 3D printer. So we just started our digital workflow, or Dr. Baresel started it while scanning the patient. And this is how the digital workflow goes on. We have to do the cut design, and afterwards, usually there comes the nesting and the slicing. What this is, I'll tell you later on. Followed by the 3D printing and the post-processing. And we go to every of these workflow steps in this webinar. So the scan is always the basis for the digital workflow, no matter if it comes from an intraoral scanner, or if you scan your plaster model with a desktop scanner, or even scan your impressions with an impression scanner or desktop scanner, which is suitable for scanning impressions. No matter from where we get these data, we need the STL file which comes out of it. It's an open format. It doesn't contain the color information, but for designing a splint, the color isn't necessary actually. And then we go into the cut design software, and there are various softwares in the market already, like Exocut, Zerona, 3Shape, or Dental Wings. And in Germany since 1st of October, and in UK it will be available from 1st of November, Dentamal Connect, which is the cloud-based design software made by DMG, which we showed you already a little. You had a little preview. And in this design software, you design your restoration or your splint, for example, like today. When you're finished with designing, you have to print it, or in some other cases, you even can mill your restoration, your splint, whatever you have designed. Today we are talking about the printing, and this is the next workflow step. Before you can print your restoration, you have to prepare it. So at first you export again an STL file out of your design software and put it in your slicing software. And this slicing software is a special software for 3D printing, in which you need different steps that you can print your object. These steps are the slicing, the nesting, and the supporting of your object. And to show you this, I'll have a little video which is explaining how the whole process goes on. So we have designed a surgical guide in this case, but the whole workflow would be the same with a splint. And of course, you have to open at first the software and import. No, you have to choose which printer you want to use. It's the 3D Max like we want to use today. Now you see the build platform and can drag and drop your printing object like this surgical guide or drilling template. Now you have to rotate it to the occlusal, so you won't have the supports on the inner surface, which will affect the fitting. Put it in the middle if you only print one object. And then you have to select and add the support structure. There are different support styles. In this case, we will use, of course, because it's a surgical guide, we will use the surgical guide support script, which is already chosen. There are some other ones, and we have to lift our parts before supporting those so that we can remove them easier after printing from the platform. This is how the supports look. Why they are so necessary, I'll come back later on. Now we create a base grid as well, so the connection of the printed object to the build platform is better. So we have this option of adding a hexagonal grid, and this is added in the form of the shadow of the printing object. So, and when this is done, we have to choose which material we like and which thickness of our of each layer we want. So because it's a surgical guide, we use the material for surgical guides from DMG, which is Luxaprint Ortho. We use a layer thickness of 75 microns, and now we create the building job, which comes with a projection of each layer. And we'll see this now. This is the first layer. Where it is white, the material will cure. Where it is black, the material will stay liquid. And this is how every layer will get printed. And you can send this to the printer via LAN or WLAN, wireless LAN, or use an USB stick. So if we're done with all this, we can start the actual printing at the printer. And these are the printers from DMG, the 3D Lite, the 3D Max, and our post-processing units, the 3D Wash and the 3D Cure. Let me say a few words about the basic principle of 3D printing. And as you can see in this short video, the whole object is built up in layers. So each layer gets cured, then the build platform raises one layer and the next layer gets cured. This is only the basic principle. The technology which we use in our printers is the digital light processing, short DLP. And in this, each layer is projected as a whole image, a digital image by a projector. So by this light, the layer gets cured. And there are other technologies like for example, the SLA technology, where a laser point goes to every point of this layer which needs to be cured. And of course, this is slower, and projecting the whole layer at once is a lot faster. Here again, a short diagram of how the technology works. We have the building platform, or the build platform, which is on the top. This is the printed object, which will stick to the build platform. We have the material tray with a resin inside. It's a photosensitive resin. And we have the projector, which produces the projector image through the transparent bottom of the material tray. So these are our 3D printers. This is our hardware, which are one part of our DentaMile principle. And you will see this visual a few times more in this presentation. So you can always recognize it as part of the DentaMile principle. And how the printing looks inside the printer, I have here a short video. So the blue light is where the part gets cured. And we print here more than, I think we print 3 splints at once, which is possible with 3D printing. And after a layer gets cured, the whole platform rises up. New material can flow to the parts where it was cured, and it goes down, and this continues until the whole object is printed. As I told you about the layer thickness, here you can see in a short video the difference. If we have a higher layer thickness, the printing job is faster, but on the other side, you will get a rougher surface because we have less layers, and this leads to a not so fine layers. And that you can imagine this better, we have here a picture of 2 splints which were printed with 100 microns layer thickness and 50 microns layer thickness. And here you can see the difference in the printing. But of course, it is faster when you use a higher layer thickness. Here's a little example why supporting is so important, because we have here this minion figure, and one of his fists or arms is supported. The other one isn't supported. And here you can see it again and a little bigger. And what we expect from this printing job is that we get the whole object, of course, but what we actually will get is this, because this fist has no chance to stick to the build platform and will only stick to the shoulder of the minion when we come to this point. So this is why supporting of a printing object is so necessary. Here you can see a few examples of different dental printing objects which are supported, like trays, crown and bridge, surgical guide, or castable framework. And when the printing is finished, we have to do some post-processing, which goes first into the cleaning process, and after this we have the post-curing process. And I will show this to you later on. But now we talked enough about the theory. Now I'll show you how we actually design in Dentamal Connect, which is, and I'm very happy to say this, a software which won already the German Innovation Award 2020. So it's award-winning software, and I'm happy to show this to you now. So I stop the presentation, go back into our browser, and we'll go on now with the design process. I maximize it, and at first I set the occlusal plane. Usually I would set the occlusal plane in the bottom jaw, but because we already have opened the bite, or Dr. Baresel opened it, this would be false. So now I'll choose the occlusal plane by setting 4 markers on the surface, and now we have the occlusal plane. Now you can see here the front perspective, and from the left perspective, this is our setted occlusal plane. And if I'm happy with this, I can go on by clicking on the next step. It's all cloud-based, so it runs on the internet. So sometimes it needs some calculation, even a little longer now, because I stream this in real time via Zoom, but it shouldn't take too long. And when it's ready, I have different options. Now it's ready, and we can see it's exactly how Dr. Baresel scanned it. And here I have different options, like I can open it even more, but I won't do this because this is the exact position which were chosen. I can also have a look on the protrusion and the lateral protrusion in both directions. And even if you can't see it, it's a fully adjustable articulator. These are our condylus, and here we have the option of setting some parameters like the condylar inclination for left and for right, the Bennett angle for left and for right, and we can design an incisal guide with the different angles. So if we would have all this information, we can enter it and make it really fully adjustable to each patient. If I made here some wrong entries and I'm not sure, I can always set back to the default values. And we will use these default values today. So next step, again, some calculation. And in this point, I will set the insertion direction by simply clicking on this blue pin. And here I have, to help me a little bit, some different perspectives. And I can always see how big the undercuts are. So the green areas are the undercuts ILO, which are set to 0.2 millimeters, and the red ones are where the undercut is higher. I will set it to 0.35 millimeters, so we can get a little more hold of the splint, and adjusted the insertion direction a little to the front. And if I'm happy with this, I can go on again. Now the bottom of the splint gets calculated. So all the areas which are red now get blocked out. And so we can have a smooth inner surface of the splint. This again takes some calculation time. But again, it shouldn't take too long. On the right side, you always have some instructions which you can turn on or off, which give you little hints how you can move your object, or what you have to do in this progress step. And here you already can see what will be our next task. It's setting the margin line. Here we go. Only seeing the upper jaw, of course, because we only need the upper jaw in this step. And simply by clicking, I add the first points, and I will go fast because the time is running. So I'm setting just a few clicks, and always go inside of the green areas, which is where the splint will hold later on, and never go in the red areas, because in these parts the whole splint is the whole model is blocked out, and we would have a gap between the splint and the actual teeth, which might be not so comfortable for the patient. As you can see, I only set 1 point per tooth and 1 point between the teeth. And we can adjust this in the next step. So this might look a little rough, and in fact it is, but we have all the options to adjust this later on. So we can go really fast now and just set these points. And to be honest, I won't do the perfect splint design now, because I think everybody of you who is a dentist or a dental technician has his own opinion of how the perfect splint for each patient would look like. And I'm not here to teach you how to design the splint or how the splint should look like, but how to design with Dentamal Connect. Now I'm nearly finished, and if I go onto the first point or bubble I set, the line closes, and now I have in blue the splint preview, and I can set the opacity of this on the lower side, so I can see if I'm in the right areas, and I can add points by just going onto the line. I can drag and drop them, and I can delete them by marking them and pressing the button D. What else can I do? I have an undo button here in the upper right corner and a redo button. So I think this is pretty comfortable in daily working, because if I click on the wrong point, I won't have any problems with coming back to the last step I was. So this should be enough to demonstrate how you can design a splint with Dentamal Connect, or how you have to set the margin line. And I go to the next step of our journey of designing a splint. And in this, I have again the option to adjust our vertical opening. If I see this is way too low, I can adjust it in this step. And I have another option, which is to set it from the occlusal splint, which we're designing today, to a general splint, which will have the minimum thickness of the material, which is 1.5 millimeters in every area. What I can do additionally is just simply hide the bottom jaw, and so now you can see the impressions of the lower jaw on the splint surface. So we already have some impressions. Of course, I can hide the splint as well, so I can have a look at my opening if everything is fine. It still is. And so we will go on with a nearly last designing step. So now we already have a splint, or a first guess of a design of the splint. And in the next step, I'll have the chance, or I have the chance, to adjust the outer surface of the splint. So I can add few more bytes or contact points. I can remove contact points. I can smooth the surface, but I will show you every of these tools which we have in the next step. And I think this is the point which takes the longest calculation time, but it's not so long, and we could use it for other things like preparing our printer, for example. Of course, I have prepared the printer before this, before the Interdentale, but we could do this now. So still calculating. My PC is running on highest mode. And now we are in the next step. Still takes some seconds till we see the splint again, but now we can see some more detail, like the antagonist distance with this color scale, where we can see how strong are our contact points, for example. Again, we have the articulator on the right side, where we can make all our moves like protrusion and lateral retrusion to visualize how it will behave in the mouth. And we have these tools here. Now the calculation is done, and I will hide the bottom jaw now, so you can see the purple areas where we have contact, the blue areas where we doesn't have, or where we don't have contact, but it gets near the teeth, and the green, yeah, I will call it green areas where we don't have any contact. So in the front, we don't have contact in this moment, but if we want contact, I will simply add material to it. I will choose a higher radius and a higher strength as well. I will go full strength so it goes a little faster. And simply by clicking it on and holding my left mouse button, I add material. I hope you see it. I'll go a little nearer. And as you can see, it gets light blue and it will get purple. And when it's purple, I really know there is contact. I don't have to believe there might be contact if I have a look, but there is contact in the front as soon as it gets purple. And I move a little from the left to right so that I get an even surface. Now it gets purple here. And now it comes purple in all the areas, and I will make some red areas as well, so you can see what happens when it is red. For example, here. So now there it is red, and that means that we have too much material in this area. So now I'll go to another tool, which is remove material. I will make it a little smaller and not too strong, and simply remove material in these areas, so we won't have to do too much manual work afterwards, but the fitting will be perfect when we print our object. I have another tool, which is the smoothing tool, and I'll make it with a radius of 4 millimeters, higher strength, because the surface now isn't that smooth, and I will go over it to smooth it a little more. And I could do this to every part where I did some adjustments. And this will add material where is to less material, and it will remove material where is too much material. And we can always have a look from all perspectives. We can go back and have a look at our lower jaw. And this is how you can adjust your suggestion of the splint, which comes from the Dentamal Connect software. If I'm happy with this result, and to be honest, I would do some more work usually, but looking at my clock, I will go on. We have one last approval step where we will see a preview of the splint, how it will look like in this slightly transparent optic. And if I'm happy with this again, if I won't be happy, I can go back to the last design step, of course, but now I'm happy. I go to the next step, and in this, I can choose which material parameters I want. So because it's a splint, we will use the Luxaprint Ortho Plus material, which is the splint material from DMG. At first I have to choose a printer. This is the printer which is right behind me and is paired to my software. And I will choose Luxaprint Ortho Plus 100 microns, and LED is the post-processing unit, so for the post-curing. And now I'll send it to the printer, and here you can see case was sent to printer. This is our case from now. Status is done. For example, this is not finished, so it's still in progress. And if I have a look here on my printer, and this is it, I can see there's one print shop in line, which is on hold. And now I will stop this, and we will go to the other camera. I will stop this, but I hope you still hear me. And now we go over to our 3D Max. Lothar, maybe you come a little closer so you can see the display. I will go to Start Job. And here we can see it's AAA_AAA. This is what we have done. And I will download it now to the printer, where all the slicing and supporting and nesting will be done automatic. So this is a big advantage for your whole workflow. Because this takes some time, for example, or I would say 3 minutes, I have already printed a splint, which is here. And we will use this splint to see how the post-processing works. So I will take some gloves. And now I simply loose the screw here and take it out. And this is the printed splint. And now I will remove it by simply going here and removing it. That's it. I will put this back into the printer so we can start the next printing job as soon as it is sliced. Tighten the screw and closing it because it's a light sensitive material. And now we will take this splint with the supports and put it inside our 3D wash, which is a fully automatic cleaning unit. I put it in, and I will have a short video to show you how it works inside, because it gets locked as soon as I start the process. I choose Luxaprint Ortho Plus because this is our material and it's a whole validated workflow. So the cleaning parameters are validated by DMG and the post-curing parameters are validated as well. I start the process now, and this will make some noise. I hope you can understand me very well afterwards. So now the pre-cleaning starts. We have here 2 bottles with isopropanol in it, and this gets pumped inside the device, and the whole printing object gets cleaned. And this comes 2 times, and afterwards it gets dried. When we are finished with the cleaning, we go inside our 3D cure. So I already have here a clean splint, but it's not post-cured. So it won't have the right mechanical properties, because during the printing process, it only is the layers only stick to each other, but in the post-curing, it gets its final mechanical properties. I will stop this device now because of the noise, but I think you can imagine how it will go on. The whole process would take approximately 6 to 8 minutes. So now I put the splint inside our post-curing unit. Now it is inside. I'll close it, choose Luxaprint Ortho Plus, and this makes some noise as well, because now we get a vacuum, and this vacuum is that we won't have a sticky surface after the curing is done. This process will also take some time, so we will leave it and go back into the printer, where now we can see the printing job is downloaded and it's ready to print. And now I will choose it, press select. It's checking the machine state. Here you can see how long the printing will take, and now the printing process starts. And this is exactly the splint that I designed 4 minutes ago. I think you can't see it, but inside the material tray is the Luxaprint Ortho Plus, which is liquid and it's transparent, of course, so maybe you can't see it very well, but now the printing process starts, and it will take round about half an hour. I will close it again because, as I already told you, it's light sensitive. I will stop this device as well, so the noise stops, and I will go back to the computer and go on with the presentation, but only a few slides are left. So hopefully you can see now the presentation again. And here we are again. And as promised, this is a video how it looks inside the 3D wash. So the material gets fluted into the container, and this is isopropanol for cleaning. This is the best material for cleaning 3D printed objects. And now the 2 propellers start to swirl the material around, so the splint is cleaned perfectly from all sides. When this process is done, the isopropanol and the remaining liquid printing material gets pumped away, and the drying process starts. So we have a perfectly cleaned and dried object, or 2 objects in this case, 2 splints. So this is how it looks inside of the 3D wash. I already told about a validated process, but what is the validated process? Now we're talking not only about the resin, but I have it here, which is Luxaprint Ortho Plus. And when you buy a bottle of it, of course you will get a big paper which is instructions for use. And in this you can read how you have to print it, what what devices, how you have to clean it, and how you have to post-cure it. And only if you work according to these instructions, you get a safe and validated medical device. And this is what we're talking about, medical devices. So it's really necessary to work inside of a validated process. And that is what we have done with our whole system. It's Dentamal Connect, which is cloud-based, and it connects all the devices, as you have seen, and everything is documented, and it's a validated process. You choose the right material inside the Dentamal Connect. You put the right material into the printer. You have to scan it with an RFID code, which is on the bottle. I have one here. So this is the RFID code. Can you see it? You have to scan this on the printer, so the printer knows exactly which material is inside, when will it expire, and so on. And the post-processing, like washing and curing, is also connected to this whole validated process. And this is what we call the Dentamal principle. It's fast, intuitive, and validated. Okay, now I'm ready with my presentation, and I think we're perfectly in time. And yeah, we can go on with questions.
So I'm back again. I hope you can hear me.
Yeah.
Okay, back in my day, I want to show you a few things to the end, because first of all, I just show you again a little picture from the scanner where I can show you by pressing just this one button, we can go through the scan for looking for some caries. You see on the lower side, you can enlarge it, the real picture. On the upper side, the NIRI, you can enlarge it. And you see in this case here some caries. So this I wanted to show you with a scanner. And now we go back to our patient because we prepared something. We already have such a splint from the scan of our patient. And we will now bring it to the patient's mouth to show how perfect those splints fit. So you see, this is our splint, which was printed. And we now bring it to the patient's mouth. How does it feel?
It feels perfect.
This is what we train. So, one, okay, let's see, yeah. Okay. So if we look at the cool points, it's exactly what we expected from a splint. So, I'm going to thank my patient and my team for working with me. I hope I was able to show you all the advantages or some of the advantages of digital dentistry. I hope you've seen how perfect the Dentamal Connect software works, how easy it is, and how clever it is to have a software which is cloud-based, where you have a certified workflow, because this makes really sense. And yeah, I'm really looking forward to some new tools which will be added in the future to this software. So thank you all, thank you DMG for asking me, having this lecture, and back to you.
Yeah, thank you, Dr. Baresel. So, and thank you all for this really exciting experience and yeah, being part of the whole process. So now we have 15 minutes left for all your questions, and yeah, I would like to hand over again to Mr. Kazab. We already got some questions, and maybe there will be some more.
I've got until now 2 questions. The first question is to you, Dr. Baresel. It's from Dr. Shukro. He's asking, how deep can the digital scanner scan? How many millimeter beneath the gingiva?
This is always the same question. This is a good, really, really good question. And it's the same like the other question which was asked. I think I can answer to this both question with one answer. So, first of all, everything you can see with your eyes, you can scan. If you can do an analog impression, you can even do a digital impression. If you cannot do a digital impression, you even cannot do a perfect analog impression. That's it, because the scanners, depends on the scanners, have a scanning depth from 1.5 to 2 centimeters. So you can scan, and depends from which angle you scan. So there, I never had in between 8 years a problem that I was not able to scan the margin line. But, and this is really important, and this is the problem, I think, with most of the dentists which offer not accurate scans or even accurate analog impressions to the lab. The problem is the gingival management. And this is the most important thing in digital dentistry. Because if the scanner cannot see the margin line, you will be not able to scan the margin line. Some people think that in analog dentistry, okay, I have some material where I can press it around the tooth, and if there's some blood, it doesn't matter, and I will have a perfect impression. So this is not the case. And what is really helpful is to use retraction paste for scanning. We use retraction paste for every single scanned case. And DMG has a perfect, relatively new retraction paste, which is working really, really, really good. So you can scan everything, but gingival management is the most important thing, and therefore use some paste.
Thank you very much. The second question is more an opinion. It was asked anonymously, and I'm going to read it now. The problem is, he says, that often our colleagues do not want to change anything in their workflow. This usually starts right with the preparation techniques. It's very difficult to convince people that you cannot go 3 millimeters below the gingiva. But if you don't change your workflow, the results will not be satisfying, and that has to mean that the scanner is bad. That is the main reason, in my opinion, he says that, or she says, that there are so few digital users. Do you see it the same way, Dr. Baresel, or do you have different opinion here?
Yeah, this might be one of the reasons, but as I was showing you, we have so many advantages in digital scanning and in the digital world. You have to change and think about changing. You changed from gold to zirconium, you changed to Emax, because there's a reason to change it. So you cannot say, yeah, we did it for 40 years the same way, so we'll do it another 30 years like this. You have to open your eyes and see how modern dentistry looks like. So I understand what he or she is saying. That's completely right. And you will not be able to bring every single dentist to digital dentistry. But all those who want to have a future in dentistry, who want to offer their patients really modern dentistry, really accurate dentistry, they have to think about changing their workflows, and the workflows are changing all the time in dentistry. So when I remember when I was in university, I learned things which we don't do anymore today, and this is now 20 years ago. So be open with your mind, try to think about all your workflows, and try to think about change, because you don't have to be the first one like me to go digital, but you even should not be the last one to go digital.
Thank you very much. I think we answered all the questions we got until now. I think you also agreed that we can send you any questions we get later per email, and you're going to answer that.
Yeah, for
thank
sure.
You. Yeah,
Not
thank
a
you very
problem at
much.
all.
Yeah, thank you very much. I would like to thank you from my side for you, and thank you, Fabian, for the interesting presentations and for the great demos. Thank you very much.
You're welcome.
You're welcome.
Yeah, thank you also very much from my side. And yeah, I would like, of course, thank you, the participants. And I would like to thank the speakers of today, Dr. Joachim Kreuss, Dr. Ingo Baresel, Fabian Oberhofer. And yeah, I think it was a great experience. It was interesting for all of us. And yeah, thank you auch to the team of the dental office of Dr. Baresel and everybody who's, yeah, who's behind. There's especially thanks to our education department of DMG, who supported us with all the technical stuff. And yeah, we hope you enjoyed our today's program.